Hey everyone, and welcome to today's Explainer. So, if you're a CBSE Class 11 Informatics Practices student, or honestly, just anyone looking to nail down the absolute basics of Python programming, you are in the exact right place. Today, we're diving deep into Chapter 5, Flow of Control. Now, I kind of want you to think of the Python interpreter, the actual engine running your code, as a driver on a road trip, right? Without instructions, a car just sits there in the driveway. But when you give it directions, it moves. Sometimes it drives straight, sometimes it takes a detour, and sometimes it just goes around a roundabout a few times. By the end of this explainer, you are going to be the ultimate navigator for your code. Let's get into it. Okay, so here's our roadmap for the trip today. First up, controlling the code flow. Then, making decisions with conditionals. After that, we'll look at repeating actions with loops. Fourth is jump statements, specifically break and continue, and we'll wrap it all up with essential exam takeaways. All right, Section 1, Controlling the Code Flow. Let's start with the basics. So what do we actually mean by flow of control? Well, it's basically just the order in which Python executes the statements in a program. Think of it as the specific path the computer takes to read and act on your code. When you write a script, Python doesn't just look at it all at once in some chaotic jumble. No, it reads it systematically. Understanding this order, and honestly, more importantly, learning how to manipulate it, is literally what separates a super basic script from a dynamic, intelligent program that can actually react to things. Pretty much every program you'll ever write breaks down into just three main types of control. First, we've got sequential control. This is like driving straight down an empty highway. Python reads line 1, then line 2, then line 3, just executing statements one right after another. Super simple, right? But life isn't always a straight line. That brings us to conditional control, where execution depends on a condition. These are your forks in the road, like if the light is green, go. If it's red, stop. And finally, iterative control, where statements are repeated. Think of these as those traffic roundabouts. You just keep circling the roundabout, repeating an action until it's finally time to take your exit. Mastering these three paths, that gives you total command over your Python code. Moving right along to Section 2, Making Decisions with Conditionals. Okay, let's look at how these conditionals actually evolve step by step. Step 1 is the absolute most basic, the if statement. You use this when you want a block of code to run only when a specific condition is true. Like, if it's raining, take an umbrella. If it's not raining, Python just ignores the umbrella part and keeps on driving. But what if you want a backup plan? That is Step 2, if else. This lets you choose between two distinct alternatives. If it's raining, take an umbrella, else take your sunglasses. You're guaranteeing one of those two things is going to happen. And finally, Step 3, if elif else. That elif is just Python speak for else if. You bring this out when you've got multiple conditions to check. So if it's raining, take an umbrella. Elif it's snowing, grab a heavy coat. Else, just take your sunglasses. It lets your program handle completely nuanced, complex, real-world scenarios. Now, when decisions get a bit more complicated, we bring in the nested if. A nested if is exactly what it sounds like. An if statement stuffed inside another if statement. Imagine you're figuring out what to eat for dinner. Your first decision might be, if I go to that new Italian place, right? That's your first if. But once you actually get inside the restaurant, you have to make another decision. Like, if they have the lasagna, I'll order it. That second decision only even matters because the first decision happened to be true. In Python, you just indent a second if block right underneath the first one. It's an incredibly powerful tool for drilling down into really specific multi-layered situations. All right, Section 3, Repeating Actions with Loops. Python actually gives us two main ways to build these iterative traffic roundabouts, the while loop and the for loop. Let's break them down. A while loop keeps running its block of code as long as a certain condition stays true. It's basically saying, keep driving while the car still has gas. You don't necessarily know how many exact miles you're going to go, you just know you'll stop when the tank hits 0. On the flip side, we have the for loop. The for loop is used to iterate over a specific sequence or range of values. This is way more like saying, drive for exactly 50 miles. You know ahead of time exactly how many iterations or steps the loop is going to take. Knowing when to use a condition-based while loop versus a sequence-based for loop, that is a huge part of writing really clean Python code. Okay, listen up, because here is a massive trap that catches students on the CBSE exam every single year. When you use a for loop paired with the range function to generate a sequence of numbers, the stop value is not included in the output. No way. If you tell Python to calculate range 1 to 5, it's going to generate 1, 2, 3, and 4. It literally stops before it hits 5. Just remembering that the range function goes up to but does not include that stop value is absolutely going to save you points on your exam. Mark my words. Next up, Section 4, jump statements, specifically break and continue. So sometimes you're cruising along inside a loop, something unexpected happens, and you just need to alter the flow right then and there. Python gives us 2 jump statements to handle this: break and continue. Let's talk about break first. The break statement terminates the loop entirely. If your code hits a break, it's like taking an emergency exit ramp right off the highway. Boom. The loop stops dead in its tracks, and the program just moves on to whatever code is next. Continue, on the other hand, is a little gentler. The continue statement just skips the rest of the current iteration and jumps straight to the start of the next one. Imagine you're listening to a playlist on loop, right? A song comes on that you just aren't vibing with. Hitting continue is basically just hitting the skip button. You don't throw the whole music player out the window like a break statement, you just skip to the next track. And finally, Section 5, essential exam takeaways. All right, here is your ultimate Chapter 5 cheat sheet. This maps every core concept directly to its purpose. First, our decision makers. If for a single true condition, if else when you have 2 alternatives, if else for multiple paths, and the nested if for decisions inside of decisions. Then we've got our repeaters, the while loop for condition-based repeating, the for loop for sequence-based repeating, and that sneaky range function for generating numbers. And remember, it drops that stop value. Lastly, our jump statements, break to bail out of the loop entirely and continue to just skip the current iteration. Honestly, if you can lock this table into your memory, you are going to be in fantastic shape for your Class 11 IP exams. And just like that, we've reached the end of our journey for today. You now have the fundamental building blocks of Python's flow of control. You aren't just writing static list of instructions anymore, guys. You are writing smart code that can actually think, choose, and repeat. So my final question to you is, with all these conditionals and loops firmly in your toolkit, what will your code decide to do next? Don't just study these concepts. Open up Python, type out some loops, nest a few if statements, and just watch your logic come to life. Thank you so much for joining me on this explainer, and hey, happy coding!